Good morning everyone. Jai Hind. I am Ankita Sharma, working here as an assistant professor in Ajay Kumar Garg Engineering College in ECE department. So today we are going to cover our complex topic number 3, which is a very important topic, special function registers in 8051 microcontroller. So if you closely look at the topic special SFRs, we call them SFRs also. So SFRs are very important special function registers. So if you see the university paper of previous years, you will definitely see a question on SFRs, special function registers. And as the name suggests, special function registers, there are some registers, there are some number of registers which are used for some special function, which have a special function. So let's start. SFRs, special function registers. The question can come in both the types. It may come like describe the SFRs in 8051, or it can also come like this, explain or describe the special function registers. Both are the same thing, SFRs and special function registers. So as we all know, in microcontroller 8051, we have a RAM that is of 128 bytes and there is a ROM which is of 4K ROM. On-chip ROM I am talking about. I am not talking about the external ROM which we can associate later, but I am just talking about the on-chip memory which we get. So 128 bytes of on-chip RAM, that means it is available by default on-chip RAM, and if I want to exceed it, we can have it externally. Similarly, on-chip ROM is 4K bytes, which is extendable or expandable up to 64K in totality. In compare to 4K RAM, we can have 60K ROM. 4K ROM is there on chip and 60K ROM can be added also. But this is not the case of RAM. RAM we have only 128 bytes. The normal 128 bytes which we have for RAM is used as we have done this in memory organization as well. 128 bytes contains of the register banks RB0, RB1, RB2, RB3. These 4 register banks were there. After that, there was bit addressable memory which was from 20 to 30H, and after that we were having 2FH, and after that we were having the next part which was scratch pad from 30 to FF, 8F. So that portion we can say is of 128 bytes. That was a one part of RAM, and the another part of RAM which we called as, which is used as SFRs, special function registers. So this upper 128 bytes are called as SFRs, and we have 21 of these bytes. We have 21 SFRs, that is why it is 21 bytes of these, and all the registers here which are associated with microcontroller 8051 have a special function individually. That is why they are put under this category of special function registers, and some of these registers are bit addressable and some are byte addressable. Now when we talk about bit addressing and byte addressing, what actually happens when I have to apply some instruction or do something with one proper byte, that is 8-bit, it is known as the 8-byte addressing, because we have to deal with the proper full byte which is byte addressable. And next is bit addressable when we are dealing with only single byte, that is P1 is our port 1, and when we are taking P1.3, point 3 means the third bit of port 1. When we are dealing with only single bit, that is why it is known as bit addressing. So this is the difference between bit and byte addressing. This question also comes in exam in 2 marks. Explain what the difference between bit and byte addressing, or simply explain or define bit addressing and byte addressing. So the address of bit 0 of the register will be same as the address of register. So it will be same for the RAM and the normal SFR. These are the SFRs, various SFRs which are used in 8051, which is used to program and control various on-chip hardware peripherals. First of all, as we all know, the 128 byte of address is from 80 to FF. But before this, it was from 00 to 7F. From 00H to 7FH. which was used by the RAM, internal RAM only. This 128 byte space are used by the SFRs. So first of all, SFRs are characterized by these registers. We have characterized them by their use. First is the math registers, that is A and B. A register is accumulator, B is B register. Status register is our PSW, program status word. Program counter is PC. There are 2 pointer registers, one is for data pointer, one is for stack pointer. There are 4 IO ports. There are 4 input output ports in 8051, which is P0, port 0, port 1, port 2 and port 3. There are several peripheral data registers, which is TL0, TH0, TL1, TH1, which are used with the timers also. Next is peripheral control register to control the peripheral device. These are individually, if I talk about the individual register, these registers are very important because these 3 register or these 6 registers cover further 3 topics individually from the unit 4th and 5th from microcontroller itself. We will discuss these later in the next complex topic discussion, but here we will do with peripheral data registers only. Next is, this is a chart of SFRs. If you closely look here, there are hexadecimal address. So there are some address which are associated with the particular register. For example, accumulator is having a permanent fixed address, a hexadecimal address, which is E0H. So whenever in any instruction, if address is given like E0, that means we are associating with the accumulator only. Similarly, B register is having address F0. A 0 is extra here. If you closely look here, it is written as 0E0. As you all know, in microcontroller, when the alphanumeric number comes like from A to F, the hexadecimal counting is from 0 to F. 0 to 9 is a decimal number, but after that 10 is designated by A. B is represented as 11. 11 is represented by B. In hexadecimal number from A to F, when we have to write the hexadecimal number from A to F, we just write it with a preceded 0. A 0 is written before the hexadecimal number so that the controller or the processor or the machine can differentiate that the given number here is not an alphabet. It is a alphanumeric, or we can say it is a hexadecimal number. So just to differentiate between that, this is not a normal alphabet, it is a hexadecimal number. That is why all the numbers lying between A to F in hexadecimal number are preceded by a 0 in microcontroller 8051. This is not the case in microprocessor. This is only the case in microcontroller. So just remember this thing while you are going for the instruction set and everything. If you have written only E0, it will be wrong. Next is PSW, is program status word, which is also known as the flag register. Stack pointer register, data pointer is of 2 types. There are 2 bytes of data pointer. One is lower byte, one is upper or higher byte. 4 ports, all the port is having some address 8090 0A 0B. Next is priority control and enable control for the interrupt. There are 2 types of controls for the interrupts. Timer modes, there are 2 control registers for timer mode, timer control. There are 4 types of registers for timer 0 and timer 1. For timer 0, it is higher byte and lower byte. Similarly, for timer 1, it is higher byte and lower byte. One is serial control register to control the serial data for serial communication, to control the buffer, serial buffer, and next is the power control. So we will discuss all the registers one by one, but we have to break this video in 2 parts for sure, because in such a small time we cannot cover all the topic. So there will be a part 2 as well for this. So first of all, if I talk about the memory organization of microcontroller, if you closely look at the memory organization, all the registers you can see here are lying. Bit addressable is also there. This is 80. So 81, 82, 83, 84, 85, 86, 87 till here. So 80, 81, 82. I can write it here also, 80, 81, 82, 3, 84, 85, 86, 87. This is a whole byte. This is a whole byte. And when we are pointing to single byte, suppose data pointer lower byte is 82. Data pointer lower byte is 82. You can see here, it's 82. That means this is bit addressing. Only single bit is addressed by data pointer's lower byte. This is the concept of bit addressable registers. It is written here also, bit addressable registers. First of all, the most important SFR is the accumulator. Accumulator, we all know, is used for the mathematical expressions, or we can say it is used for the arithmetic and logical operations. The result will automatically store in the accumulator. It is one of the special function registers. Register A is located at the address E0H. We can also write it E0H preceded by a 0. But this 0 does not mean anything. It just supports the hexadecimal number. Some of the operations where the accumulator is used is arithmetic operations, logical operations, and data operations, data transfer operations. In all these instructions, we use the accumulator. Next is B register. Like in B register, there are two instructions in microcontroller which were not the part of microprocessor. There are two instructions, one for multiplication, one for division, and these two instructions have B register. So B register basically is a kind of temporary register. It works as a temporary register, and this register is only used in the multiplication and division instructions. That's it, not in any other instruction in microcontroller. So these two instructions, if you specifically look here, MUL is multiply AB and DIV is divide AB. In these two instructions, B register will be there. Other than that, B register is not there in any instruction of 8051. If I talk about multiply AB, what will happen? A's contents will be multiplied with B, and upper 8 bits of the multiplication bit will be stored here and remaining will be in another register. And if I talk about what the B is doing, B holds the second operand initially, which will hold the part of result after the execution, and it will also store the remainder in case of division. It will store the part of remainder in case of the division, and we can also use it from SFR by address F0. We can see it from here also, F0. B registers hexadecimal address. This is also a bit addressable register. Next is data pointer register. So data pointer is further divided into two parts. One is lower part and one is higher part. So we are having two 8-bit registers which can be combined to compile or to create a 16-bit data pointer. Data pointer is generally used to access the external memory. Other than that, we do not use data pointer. For example, this is an instruction which is given. I have taken it from 8051 instruction set. Move dptr comma hash data 16. Hash data 16 means there is an immediate 16-bit data given. That particular data will be copied to this data pointer. Move x a comma at the rate dptr. Now dptr is indirect address, and at particular indirect address the contents will be copied to accumulator. And which indirect address? The external memory, because x is there which is showing the external memory. And these are some other examples also. Move c, code byte is represented by c here. Move x, external memory is represented here. At the rate represents the indirect addressing mode because the contents of data pointer will act as a memory here. So these are some data pointer examples. And data pointer can also be used as two separate 8-bit registers, and we can use it in instruction set as well. For example, DPL. DPL means data pointer's lower byte will be loaded with this 8-bit data which is given, and we use the programmer use this for addressing external memory, program memory and data memory. There are two types of memory, program memory and data memory. So DPL's address is 82 and DPH address is 83. Next is stack pointer. Stack pointer, we all know it works on two principles, push and pop. So when push operation is there, that means we are incrementing the stack pointer, it will copy the data. Pop means it will decrement, it will first take out the data and it will decrement the stack pointer. Similarly, in microprocessor, it is same, and we have these register banks 2, 3, 4, which are normal, and SP stack pointer is pointed by register bank 1. RB1 is used as a stack pointer. And when the microcontroller shuts down and it again power up, the contents of this by default are 07H because it is pointed by RB1. There are 4 types of special function registers in microcontroller, or I can say there are 4 types of IO ports: port 0, port 1, port 2, port 3. These 4 input-output ports are basically used for the input-output functions. These act as a peripheral devices. These can be used as IO ports as well. Now, out of these 4, PO is used as input-output port as well as demultiplexed address data lines. So, PO is also used as AD0 to AD7. Port 2 also used as A8 to A15. That means higher order address. P3 is the most special port. Most special port because every bit of port 3 is assigned with a different function, and port 1 is the only port in microcontroller 8051 which act as only input output device, nothing more than that. It just has one function, which is IO, act as a IO device, IO register, that's it. So P1 is the only, port 1 is the only register which works as only input output port register. Next is, this is also important topic, program status word. A 2 marks question can also come in between from this part. This is an 8-bit register known as program status word, which shows the contents of, which reflects the contents of accumulator, which shows the status of the word, which is program status word. Here we can see 8 bits are there: 0, 1, 2, 3, 4, 5, 6 and 7. Every bit is having a different function. 0 means the parity flag. This is a parity flag. First bit is reserved. Next is overflow flag. Next RS3 and RS0 and RS1. These 2 pins are very important. Here you can see RS0, RS1. The combinations for these 2 inputs can be maximum 4, 0, 0, 0, 1, 1, 0, 1, 1. These 2 bits RS0, register select 0, register select 1. These 2 bits are generally used to select the register bank from the RAM. If it is 0, 0, register bank 0, register bank 1, register bank 2, register bank 3. The 4 registers are selected simultaneously with the help of these bits RS0 and RS1. And similarly, these addresses are already provided by here for the register banks. Next is F0. F0 is flag 0, available for the user for general purpose. Extra AC is auxiliary carry flag. When the carry occurs in between from lower nibble to the upper nibble, that carry is called as the auxiliary carry. Next is CY, carry flag. When the 9th bit after the result occurs, it is called as the carry flag. The 9th bit is called as the carry flag. This is the program status word. This is the description for all the flags. Carry flag is 1. That means we have to set it. Carry flag is 0. That bit is 0. That means we have to clear it. Auxiliary carry, if it is 1, that means there is a carry. If this bit is 0, that means there is no carry. For RS0 and RS1, it is explained here. For parity, if the parity is 1, that means there are number of ones are odd here. And if parity is 0, that means even ones are there. This is opposite. as compared to microprocessor. In microprocessor, it was like if parity is 1, this shows that number of ones are even, but here it is different. If it is 0 here, which means number of ones are even here. For the overflow flag, here this flag is set whenever the result is a signed number. If the operation is too large, it is the overflow flag. These are further the peripheral control registers, which we will discuss in the next class, because it will be an important topic. Before that, we can just discuss about the P control, which is power control. The P control or the power control register, basically as the name suggests, we use it to control the microcontroller 8051 power modes, and we know PCON is located at 87H, and 2 bits we use here, which is used to set it as a idle mode or a power down mode. So there are 2 modes for controlling the power. One is idle mode and next is power down mode. During idle mode, what actually happens, the microcontroller stop the clock and it will just stop the work, and when it want to terminate, it will terminate the idle mode and it will use an interrupt or hardware reset. Next is power down mode. In power down mode, the oscillator will stop and the power will be reduced to 2 volt. And to terminate the power down mode, we have to use the hardware reset only. And apart from these two, PCON register can also be used for 2 additional purposes. One is S mode bit, and in the PCON register, which is used for the baud rate in UART, Universal Asynchronous Receiver Transmitter. And next is two general purpose flag bits, which we will discuss in PCON register. So this is the PCON control register, which is very important. Power control register, this is the register for PCON. First of all, the 0 bit is idle bit, next is power down, next is general purpose bit for user, general purpose bit for user, 3 bits are saved for future, and next is S mode, which is used for the baud rate. When this pin is 1, the baud rate is doubled in UART. In UART modes 1, 2, 3, and when this bit is 0, there will be no effect on the baud rate. And if we talk about the power pin here, if this pin is 1, that means power down will be enabled. Power down will be enabled here, and all the oscillator clocks and the peripheral devices will be off. They will stop working and hardware can cancel this mode at any time. If I just reset the hardware, then this mode can be cancelled. Power down can be cancelled by resetting the hardware. Next is idle mode. In idle mode, if this bit is 0, that means I am just disabling the idle mode, and when IDL mode is enabled, that means controller clock is turned off and it will reset it by the hardware reset and interrupt reset. Only these 2 things can cancel the idle mode. Otherwise, it will just switch off the clock timer, which will affect the timer, serial ports and interrupts. These works normally, but the clock remains off. So these are few topics from PCON. We will further do the remaining topics in next class. These are the references. The textbook which we follow here is Microcontroller Embedded Systems Using Assembly and C by Muhammad Ali Mazidi, which is a good book, which is a textbook. This is the link. Thank you. Thank you so much.